All right. We want show say speed now equal to wavelength times frequency. Now what we want show you today. Now before I go show you say speed now equal to wavelength times frequency, I go show you the wave diagram. I'll show you first of all the wave diagram. Because now that wave diagram, now I go take get wetin I dey look for. Now make I show you wave diagram. I go draw them very small so that you go see them. Now this one now wave diagram. Now you get wave where they move like this. So now the wave diagram be that. I go tell you wetin this information, wetin the some of the information where this wave diagram carry. I go tell you. Now just dey follow me. Now this wave diagram, the time in seconds, and this one na the speed or the distance. So wetin this wave diagram carry? Now the first thing wey the wave diagram carry na amplitude. And wetin be amplitude? Amplitude na the maximum vertical distance reached by a wave body. Now but that one no be our concern. First thing wey you go know, let's define period. Period be say period t. Period be say na the distance or na the time taken to complete one oscillation, na be period. So period na the time taken to complete one oscillation from here to here. So this one are the period. So period, it is the time taken to complete one oscillation. So now the formula for period be that. Now the formula for frequency. Frequency now the number of oscillation per second. Number of what? Oscillation per second. So our frequency is the number of oscillation per second. Now see say period and frequency, they get the same parameters. Only say one day up, the other one day down. So I go express frequency to look like period. Okay, if I express frequency to look like period, you go see say frequency, if I take the reciprocal of frequency, I have 1 all over f is equal to t all over what? All over n. You see that these two now the same, these two now the same. So what I go do next now to equate them, you see say period now equal to the reciprocal of what? Of frequency. Shey you dey follow? I dey go somewhere, no relax, no screw, make you no screw, just take your time, make you see wetin I dey do. So I don get this one. Now I dey go get our lambda. Our lambda na the distance between two successive crests. Wetin dey call lambda na wavelength. The distance between two successive crests, or the distance between two successive trough, or the distance between 2 points in phase. 2 points in phase. So now our wavelength can be either from here to here, or from here to here, our wavelength, or from here to here. Now see from here to here, na be wavelength, and that point from here to here, na be our wavelength. So wavelength is the distance between two successive crests or trough. I don put am there make you know. Another thing, don't forget say we dey come here. Now here we dey come. So I don't talk about what? Period. I don't talk about frequency. I don't bring the connection between frequency and period. Now be this. Now I don't talk about wavelength. So now wavelength be this. Now make we talk about speed. Now the speed, you know say for linear speed or linear motion, speed now equal to distance over time. Distance over time for linear motion, that be the speed. Okay, now v, this distance wey we dey talk, na the distance wey e dey use complete one oscillation. The distance to complete one oscillation, na be our distance, and that distance now e don turn to our wavelength. So wavelength over time taken, and that time taken na the time to complete one oscillation. We talk about distance to complete one oscillation and the time to complete one oscillation. The distance to complete one oscillation na wavelength, and the time to complete one oscillation na period. So this one be period. So if we put them together, wavelength na lambda over period t. Shey you get? Now they follow. C, v na equal to, I go express this one wey match like this. If I express them, I will get lambda times 1 all over t. if I multiply am, I dey go back to this, I dey go back to this. So now wetin be 1 all over t? You know say if you express this formula to be like t, or to be like f is equal to 1 all over t. So this one now I go replace am to be like lambda f. So therefore our v is equal to lambda f. Na wetin dem say make we prove. I hope say you enjoy this video. E no hard, just follow am gently. And when you follow am gently, you go see say your answer will surface in a not